Good evening, students. I'll start with the class. In the previous class, we had seen Newton's second law of motion. Okay, what did the second law of motion say? That the rate of change of momentum is directly proportional to the force. Okay. So, change of momentum was given to you as is always will be your final minus initial. Rate of change of is nothing but Pf minus Pi upon T. Whenever the word rate is coming, it will be divided by a time. It's in force is always directly proportional to dp by dt. Then we know that force is nothing but your mass into acceleration. By acceleration, if you want to know, is nothing but v minus u upon t. Final velocity minus initial velocity upon time. And momentum, if you want to know what is p, that is m into your velocity. So this is all we had seen in the previous class. And one more thing, last one was an impulse. Impulse was nothing but given as j, that is force into time. These are all the formulae or the things which you have to know. Now based on that, we'll solve some problems. One more thing we had seen in the previous class, whenever there's any object on a surface or on a table, there will be always two forces. One is the gravity which will be acting on it in the downward direction, and one will always be in the opposite direction, that is called as a normal. When it is hanging, then it is called as tension. These are the things we are. Question. With a mass of 10 kg is being pulled by 20 newtons. There's a force which has been applied of 20 newtons. Calculate normal n which is there and acceleration. These are very simple problems. You just have to try to understand this. That's the question. There's a 10 kg which is been pulled with a force of 20 newtons. Obviously, whichever side the object is moving, on that direction your acceleration will be there. So you know that the object is accelerating in this particular direction. We'll simplify the diagram now. If this is the diagram, we know that there is always a gravity acting upon it, that is m into g. And this is always n, 10 kg. Force is 20 newton. Now we'll calculate what is, we know that always this force will always be equal to this force. Force of gravity will always be equal to your normal. So as per that, your vertical forces you have to equate. N will be nothing but m into. If there was one more force, then they would have got added in the same direction. There are two forces, no? One more was there here. Then this and this would have got added if they are both going the same direction. If one was coming in the opposite, then they would have got minus. But now there's only one, so directly straight away this is equals to this. So if we consider this as 9.8, this would be 10. Okay, so 98 Newton. Force will always be measured in terms of Newton. So we got the first one. Now force is being given. We know the formula. What is force? Is nothing but mass into acceleration. So mass we know, how much force, that also we know. So we'll just substitute. So acceleration is nothing but force upon mass. So how much is it? 20 upon 10. So it will be 2 meter per second square is the acceleration. If anyone has not understood this, then ask them. Calculate normal and acceleration. Now there are two forces which are acting on that. We'll see. This is a mass. In case of given in terms of numbers, you can solve in terms of numbers. Now normal letters are there, so we just use it as there will be a normal, there will be gravity, there is a force this side, there is a force this side. Now they are saying F2 is more than F1. So like there's a person A trying to push the object this side, there is a person B who is trying to push the object this side. But the fellow who F2 is having more force. So which side will be the object moving? In the positive side or in the negative side? Which side will be the acceleration? This side? First case or the second case? Which side will be the acceleration? F2 is more than F1. So acceleration is always across along the direction of the moving object. So which side object will be moving and which side will be the acceleration? First case or the second case will be acceleration? Which side? F2 is applying more force. His force is stronger than F1. So which side object will move? To right hand side or to left hand side?
Left hand side.
Hmm? Left hand side object will move.
Right hand side.
See, this side, this fellow is suppose applying 20 newtons. This fellow is applying 10 newtons. So this one will overpower this one. No. Obviously, this one is stronger. So his force will overcome this one. And the object will move this side. The object is going to move this side in the first case. The acceleration will be this side. Overall acceleration. I will calculate the normal. Normal will be straight away equals to m into g. So if the mass was given, you have to directly calculate, multiplied by the given as 9.8 or 10, whichever has been asked. So this is your first thing. And we got, now here, force is equals to mass into acceleration. Now total force we have to see. Force means how much it will be. Now they're in the opposite direction. So opposite directions means they will always minus each other. So this will be bigger force minus the smaller force. Okay, because this is positive side, so we'll take F2. This is in the opposite side, so that's why it will be minus. F2 minus F1 is equal to mass into acceleration. You have to calculate acceleration, it would be what? F2 minus F1 upon m. This is the answer. Now, if they were in the same direction, then it would be force is mass into acceleration. So for total force is what? Addition of both, because they are both in the same direction. If they are in opposite, then you have to minus. Any doubt related to this? Then ask. This is theta, this is F, this is mass. Calculate same n and acceleration. One second. Now I want to know which side will be my acceleration, in which direction the object will be moving. Now the string, it's like a string which is tied to the object. Even though if you see it's pulled at an angle, obviously this one will not start moving as exactly as this way. See, it's like having a toy. Okay, a small kid is having a toy in the hand, and you are holding the string in the hand. If the person is pulling the string, even at an angle, what will happen? It will move along the surface only. Okay. Anyways, acceleration will be in this particular direction. Object will move this way. You can just remember that example. If you are pulling a toy, okay, a kid is playing with a toy and trying to pull the toy with a string. It will anyways move on the floor. Now this is at an angle. So whenever any force is at an angle, we'll always have two components. This is a force. We'll have two components. One will be the horizontal component. One will always be the vertical component. This is your theta. So whichever line is attached to theta will be always your F cos theta. The opposite component will be F sin theta. This is mass. So there will be mg. There will be n. Now we'll put it in the proper form. Even though it is at the corner, how it will look, the final, this will look like this. There's one force. Put all the vertical forces together. There's one force here. There's one more force, that is F sin theta. The horizontal force is F cos theta. This will go now because we have resolved f into two components. This will be your final diagram. It would be so as per that, as per this diagram, what will be the first equation? The vertical forces will always be balanced by a upward forces will be balanced by a downward forces. They are both going in the same direction. So they'll get added. So n plus f sine theta will be equals to your downward. So what will be your normal? Take I want to calculate n. N will be nothing but take the remaining fellow on the other. So this will be your answer. Mg minus f sine theta. I want to calculate force. So force is nothing but mass into acceleration. So which is your horizontal acceleration is in this direction. So what is that force? Force is nothing but your f cos theta. So now the horizontal is f cos theta divided by n. So that's the answer. If it was given in terms of value, you have to substitute the value. Next question. This is 37 degree, 20 Newton. This is 50 degree, 10 Newton. This is your F1 and this is F. Calculate normal and acceleration. Now look at the arrows. This is like this the person is trying to push the arrow, force is coming towards this, so this is pushing and this is pulling. So anyways it will go in this direction only. The acceleration will anyways move this side because force a person A is pushing it and the person B is pulling it. So it will move along this direction only. The acceleration will be in this direction. Now there are two of these forces, will resolve both of them. So this one will resolve first. This will be how much? This is 53 degree. So this is considering F1 as 10 Newton. So always you have to resolve from this part. So one will be a horizontal component, one will be a vertical component. So the one which is attached to theta will be what? F1 cos theta. This will be F1 sin theta. So how much is the F1? Nothing but which is equals to 10. What is cos 53? So all the values from the triangle I told you, and it is a 37-degree triangle and a 53-degree triangle. Directly can by heart of and keep. Cos 53 is always 3 by 5. Sin 53 is always 4 by 5. Cos 37 is 4 by 5. Ulta it is. And then sin 37 will be 3 by 5. So these are the values of cos and sin for both the angles. Now cos 53 will be 10 into, it will be 8. So this horizontal component is 8. Calculate this one. If one is 10 times the sine theta, so sine of 53. So 10 into sine 53 is how much? 4 by 5. Oh, this is 3 by 5, no? This is 6. This is 4 by 5. So this will be 8. So for this one, this is 6 and this is 8. So we have resolved F1 into two components, horizontal and the vertical, and we calculated it. Same way we'll resolve this one, F2. So we'll resolve it into two components. One is the horizontal, the vertical. Where is the angle? Here. So theta is attached here. So this will be cos theta. This line, whoever is attached to theta is always cos. So that is nothing but 20 times cos of 37. Cos 37 is 4 by 5. 5 4s are 20, 16 Newton. And this will be 20 into sine 37, 3 by 5. It is 12 Newton. So I've resolved both the forces into its component. We'll draw the final diagram. See, this is the box. Now look out for all the vertical this. One is your normal, this is a basic thing. One is your mg. This will be your first thing. No. With respect to this point. Now this is going in which direction? Horizontal direction. Horizontal means either I can mark like this here, or I can put here, whichever way, doesn't matter. We'll put it here. So how much is it? The horizontal, that is 6 Newton. This is going vertical. Either I can put here upwards or I can put it down. Doesn't matter. Downwards, so it is 8 Newton. Here also I can put, no problem. Then this is done. Look out for this. This is going upwards. Upward means 12 Newton is going up. And this side is horizontal. So horizontal is 16. So this is the final diagram. Now balance your vertical with this. So we know that this total is equals to this total. N plus 12 newtons. Will not put the values. This is a normal. This is 12. Will be equals to 8 plus N. Mass was given to me as 5 kg. So we'll take it as gravity as 10 to simplify. N is 46 Newton. Now we want to calculate acceleration. Force is mass into acceleration. Force is nothing but same along the acceleration side. So what is the total force now acting on the horizontal side? Nothing but your 6 plus 16. Both are in the same direction. So whether I had put it here no at 6n or whether I had put it here, anyways it would have got added. So 6 plus 16 would give me, this is 5, 22 by 5. So 5 4s are 20. That is your acceleration. Now this was based on normal finding this acceleration in the normal. Next one, next problems will be solving based on momentum and impulse. The first question, a batsman hits the back of ball straight in the direction the bowler without changing its initial speed. If the mass of ball is 0.15 kg, determine impulse imparted on the ball. So this is the question. So there's a ball which is coming towards the batsman. So the batsman this hits the ball back. But what is happening without changing its speed? So when if it's coming at 12 meters per second, it will go back also at 12 meters per second. Mass of the ball is 0.15 kg. So how it looks like as per this, there's a batsman suppose over here that is coming and it is going back. So if it's coming at 12 meters per second, it's going back also at 12 meters per second. Came and then it went back. So this one's arrow is in this direction and the ball is going back in the opposite direction. Determine the impulse. So we know that impulse is nothing but, we have proved also, is equals to change in momentum. we have seen the relation between impulse and the momentum. It's not what is change in momentum? P final minus P initial. Okay. So dP is nothing but change in the momentum. If you want to know this, yeah, dP also it is called. dP is Pf minus, this is mv minus mv. If you want to write in words, this is final momentum and this is initial momentum. Okay. It's understood anyway. So we can directly write mv minus m. Now, coming velocity is u, going velocity is v, like final. But now this is in the opposite direction. So remember that you cannot take the same signs for both of them. So v will be in the going back direction, it will be negative then. So we have to take v as minus 12 meters per second. So mass will be how much? M is given to me as 0.15 kg. V is, u is coming at 12 meters per second. V is going at minus 12 meters per second. Now substitute the value. M is anyways common. So what you can do, take out common. Or you can multiply separately also and calculate, no problem. This is 0.15. This is inside the bracket. This is minus 12 and again minus, will be 0.15 into minus 24 and then calculate. So that will turn out to be minus 3.6 Newton second impulse. Impulse formula is Newton, unit is Newton second. Anyone who has not understood can ask. Anytime is like this, velocity has been given, now initial speed and the final speed has been given. Remember that impulse is always equals to change in the momentum. So you just have to find out Pf minus Pf. Next question. A cricket ball of mass 150 grams moving with a velocity of 15 meters per second is brought to rest by a player in 0.05 seconds. Calculate the impulse and average force exerted by the player. Two things we have to find. One is the impulse and the other one is the force. So what all data has been given, we'll write. So cricket ball of mass 150 grams. Now you see, question is given in terms of grams and rest all are in terms of standard units, meters per second and all. So mass we have to convert in standard form, that is in kgs. So grams into conversion, we have to always, 1 gram is what? 10 raised to minus 3. That will be equals to 150 into 10 raised to minus 3 kg. Minus 3 means what? You are dividing it by this. So we have to make it smaller. Grams to kg will become like this. So minus 3 means 3 decimals point this side. So 1, 2, 3. So that will become 0.15 kg. It's like taking this down to the denominator. So it's like dividing by 1000. When you divide by 1000, you have to move 3 decimal places on the left hand side. You can get it as 0.15 kg. Then time is been moving with a velocity. Initial velocity will be 15 meters per second. Then it is brought to a rest. So at rest, what will happen? After moving, then the ball will stop. Rest means so final velocity will be 0. Time is been given 0.05 seconds. So this is the data given. We have to calculate impulse. So we can use the same previous formula. It's nothing but change in the momentum. Two ways you can calculate. Your teachers may use two ways. I'll show you both the method. Impulse can be directly taken as Pf minus Pi, that is mv minus mu. So m will be common, p minus u. So over here, v is 0 now. M is how much? 0.15. So this will give you minus 2.25 Newton second. This is one way to calculate your impulse. This is an easier method. Now there's one more. You know what is the impulse formula? Impulse formula is nothing but J is F into T. This or this. Now force is not been given to us anywhere. So force is nothing but mass into acceleration. Again, the acceleration is not given. The acceleration is what? V minus u upon t. This is like the same derivation type. Then t and t will cancel, and what you'll get is, so basically you end up at the same formula. And you'll get the same answer. The best option is you can remember this. Suppose force is given, time is given, then directly can use this formula. But here force was not given anywhere. We can't use this formula. That's why we have to use velocities. Same answer. Minus this is a. Now one part is done. Impulse we calculated. Second is asked is force. Now we can use this long cut method. Now we have to one method is this, or finally we have to calculate for this or this. whichever formula you want. But now in this case, since we don't know what is acceleration, then we have to use this v minus u upon t. And force will be, mass will be 0.15, v is 0, this is 15 upon time 0.05. So this will be anyways minus 2.25 upon 0.05. This is one way. Here J we have already calculated. Now J is nothing but an impulse. How much we had got? 0. This 2.25. Force is already known. Now we have to calculate. Time we already know. So minus 2.25 upon 0.05 is there. Both the ways are getting the same answer. So 2 decimals we are shifting. So this will be 225 upon 5. Forty-five it is. So whichever formula you use, you'll get the same answer. Next question. Two balls each of mass 0.05 kg moving in opposite direction with a speed of 6 meters per second collide and rebound with the same speed. What is the impulse imparted to each ball by the other? There are two balls each of mass 0.05 kg. So what is happening? Like this, one ball is coming the other way and then they collide. After colliding, they are going back. And they'll follow straight path again in the same direction. So one is of how much? Mass will be 0.05. This is also mass of 0.05. Moving with a speed of 6 meters per second. So, and again going back with 6 meters per second. So we'll take this side as minus. Again, this fellow is coming at 6 meters per second, going back at 6 meters per second. So it's nothing but, what is the impulse? Impulse is same thing, change in momentum. Okay. That will be Anyways, mass is given to us 0.05, u is 6 meters per second, v is minus 6 meters. So pf minus pi, mv minus mm, v minus u. This starting part is same like the previous problem. So mass is how much? 0.05, initial is 6, sorry, first final one, v is how much? Minus 6, again minus. So by each ball, so only one ball you have to calculate. So if this same as this, okay, if whether you're calculating for ball 1, whether you're calculating for ball 2, it's the same value because both are having same mass, same velocity. So that will be 0.05 into minus 12. 12 is a 60. So that will give you minus 0.6 Newton second. That's the impulse. Question 4. While launching a rocket of mass 20 seconds, calculate the velocity attained by the rocket at the end of 20 seconds. What is happening? There's a rocket which has been launched and calculate the velocity. So this has been done in 20 seconds. V is how much at the end of 20 seconds. So definitely when you're launching, it will start from rest, the rocket. So that will be U will be equals to 0. Mass given to me as 10 raised to 4. Force is 5 raised. Time is 20 seconds. U is 0. V is how much? Now we can use that formula. The force is there, time is there, mass is there. The force is nothing but mass into acceleration. Acceleration is nothing but change in velocity upon time. V minus u upon t. That is the acceleration form. Everything we know now. Force we know, mass we know, v we have to calculate, u is 0, time 0. Substitute all the values, then calculate. F is how much? 5 into 10 raised to 5. M is how much? 10 raised to 4. V we don't know. This is 0. Time is how much? 20. Now Denominator, you can cross multiply, take it up. I can calculate here also. This will give you 10. No need to take. Directly you can calculate. 5 into 10 raised to 5, 10 raised to 4 into V upon 10. So 110 will cancel, 3 will remain. 10 raised to 3 will go down here because we want to calculate what is the value of V. So 3 will cancel, 2 zeros will remain. 10 raised to 2 is nothing but 10 square 100. That is 500 meters per second is my velocity. Units you have to remember. For velocity it is meter per second. Acceleration it is meter per second square. For impulse it is Newton second. For momentum it is kg meter per second. Next question. A machine gun fires a bullet of mass 40 grams with a speed of 1200 meters per second. The person holding the gun can exert a maximum force what is the number of bullets a machine gun fires a bullet of mass 40 grams with a speed of 1200 meters per second. The person holding the gun can exert a maximum force of 144 Newton on it. What is the number of bullets that can be fired from the gun per second? Per second means 1 second in a second. So what all data has been given? M is 40 grams. Speed. Initial speed is no, not initial, it's been already fired. So that will be V. Initial will be what? 0 because first the bullet will be at rest. Before firing, the bullet will be at rest. Only when it fires, it will catch up this velocity. The initial will be 0. Bullet before firing will be at rest. So initial velocity of the bullet will be 0. And it's been force has been given. Time is how much per second means 1 second. Now, how many bullets are fired? So we can consider let number of bullets fired be n. Okay, also we can. We had seen this formula is directly proportional to time. Force is directly proportional to time under the derivation part. Then what we have taken, like P is equals to K times dP by dt. Or you can take this as K only. Number of bullets fired be K. So whenever we remove the proportionality constant, we put it as K. In the derivation, we had just assumed it, let K be equals to 1. But here, we will not assume that K is equals to 1 because we have to calculate that K. How many bullets, number of this will happen within that much time. So K will keep like this only. We will not take K as 1. Otherwise, normally in all the problems, as long we don't have to calculate the number of things what are happening, we assume K to be 1. So directly we use the formula dP by dt, that is mass into acceleration. This is F. So change, this is what change in momentum. So it's nothing but K times P final minus P initial upon your time. Time is given to me as 1 second. Force is given, substitute. K we have to calculate. This will be what? mv minus mu on 1. U is 0. M is how much? Mass of the bullet? 40. 40 grams has been given, no? Starting a converter, 40 grams. So that will be 40 into 10 raised to minus 3. So decimal 0.04 kg. In terms of kg, we have to take. So this will be 0.04 kg into 1200 is your velocity. Again 0.04, u is 0, initial velocity upon 1. Anyways, 1 will go because anything divided by 1 will be 6. Time is 1. This is 48. Because if you multiply, this will go to 12 for the 48. And this is 0. So 144 is equals to 48k. So 144 upon 48. We calculate k is 3. Therefore, 3 bullets will be fired. Next question. 2 more problems. These are small ones. A ball moving with a momentum of 5 kg meter per second strikes against a wall at an angle of 45 degree and is reflected same angle. Calculate the change in momentum. There is a wall. Suppose if some ball is coming, it is hitting the wall. Suppose if this is the reference line, hitting at 45 degree and then going back also at 45 degree. It should look like proper 90. Coming at 45, going back at this. We can just consider initial momentum. It's coming with the initial momentum and going with the final momentum. This is your wall. Now anything at the angle will always have components. So we'll calculate the components for Pi first. If this is coming inwards, no? So the arrows also will have to put inwards for the this. So the one closest to this is a cos. So this is Pi cos 45. This will be Pi sin 45. Draw the diagram again, no? Otherwise you will not know what was the question given. Oh, it's okay, no problem. Only this was given, now this we are framing. So this is sin 45. Same way, what is PF? PF also has two components. Now, this fellow's directions will be opposite, going outwards along this one's direction. So this is what? PF cos 45. And this is PF sin 45 for this vector. Now, if Pi is given to me as 5, okay, kg meter per second, PF will also be 5 because it is reflected at the same angle. The initial momentum will be same as reflected moment. Because it is going back at the same angle. Now we have to calculate separately. So we'll just calculate what is the initial momentum component. I will draw the diagram again. This is for pi. So this is what pi is how much? 5. So this will be 5 cos 45. This will be sine, and this will be 5 cos 40. I'm just substituting the value. And for this one, I'll draw again. This is for PF. I'm drawing separately so that you don't get confused. So for PF, this is again 5. So this is again 5 cos 45, because this is 45 degree. This is 45 degree. This will be 5 sin 40. Calculate. This is how much? 5 into 45 is 1 by root 2. So 5 by root 2. Same way, cos 45 is 1 by root 2. That is 5 by root 5 by root 2. You'll get the answer as everywhere. This is 5 by root 2. All the components are 5 by root 2. So if you see, vertical component of the wall, they are both in the same direction. Okay, it remains the same. This is also plus 5 by 5 upon root 2. This is also 5 upon root 2. So vertical component to the wall, you see, same direction is there. It remains the same. So there is no change in the momentum. Whichever direction it was flowing, it will remain the same. There is no change in momentum in the vertical direction. The vertical was going this side only. For this one also, it is after reflecting also, it is in the same direction. But over here, see, for the horizontal, this diagram is before this hitting the wall, and this is after hitting the wall. So before hitting the wall, what is the horizontal component? Coming in this direction. But what happens after hitting the ball? The component change in the opposite direction. For horizontal component, there is change in momentum, opposite direction. Therefore, there is a change in momentum. So we'll calculate the change in momentum. This will give you what? Final minus initial 5 by root 2 minus 5 by root 2. So that is 0. 0 means there is no change in momentum, because both are in the same direction. No? So initial also is 5 by root 2. Final is also 5 by root 2. So that will become 0. For horizontal component, what it is? PF minus PI. So final is how much? Opposite direction. See, ulta it is going. So we have to take it as minus 5 upon root 2. This will be plus 5 upon. How much it will be? Minus 5 upon root 2, minus 10 upon root. Second, that is kg meters per second. For vertical, there is no change, and for horizontal, the opposite direction. No? So you have to take one is negative, the other one is positive. So this I have taken as negative because it is opposite direction. Here, vertical, they were both in the same direction, so both were plus. But as per the formula, there is a minus sign. That's why final minus initial will give you 0. Last problem. A ball of mass 0.1 kg is thrown against the wall. Strikes the wall normally with a velocity of 30 meters per second and rebounds with velocity of 20 meters per second. Calculate your impulse. Very simple. Impulse is nothing but change in momentum. J means change in momentum. Final Pf minus Pi. You know the initial velocity, you know the final velocity, you know the mass. Like there's a wall coming back in the same direction. So this is going at 30 meters. This is coming back at 20 meters. That will be minus you have to take. M is 0.1, U is 30, V is minus 20. So J is nothing but Pi minus Pf, you know that. Sorry, Pf minus Pi, Mv minus M. M is common always, and then calculate. M is how much? 30, 0.1. V is minus 20, minus 30. Minus 5 Newton. Impulse is always change in momentum. Final minus initial. So these were the problems based on force and impulse, momentum. And the last part for today's class, a small one, that is Newton's third law. Everybody knows that. Third law of motion. It states that every action there is always equal and opposite reaction. Okay, so whenever you're trying to apply some force on anyone, there's always a resistance. Okay, there's always try to oppose the reaction. Now, how much it is, magnitude and all, it depends on real life examples. Okay, if it's equal and opposite, there will be no change. Okay, so it's like how you're trying to apply some 10 newtons on this. The ball trying to put some 10 newton on you. Overall, the ball will also not move. You will also not move. Okay, so whenever equal and opposite reaction is there, there is no movement. There is no change in the motion. So there are some implications of, or like notes you can consider it as things to know about Newton's third law. The first one says this law is applicable. Just 4 points, okay, and then I'll end the class. Applicable irrespective of the forces may be mechanical, gravitational, electric, or any other force. This law applies to all kinds of forces, okay? Whether it may be mechanical, whether it may be gravitational, whether it may be electric, or any other force. We have seen under this also. Whenever a ball was hanging, when the gravity was trying to pull it, there was an opposite force called as tension, which was like a reaction to it. So the forces could be a gravitational, electrical, mechanical. Like mechanical will be actual physical force, or even magnetic force. All types of forces it applies to. Second one, action and reaction always act on different bodies. Because if they acted on the same body, the resultant force will be zero. And there would be, or there could never be, acceleration. I'll explain this point. Is just like action and reaction always act on a different body, or always act on different bodies. If they act on the same body, what will happen? The resultant force will be zero, and there would never be any acceleration. See the example. Now, there's a small box, suppose if it is there. Okay, and there's a person is trying to push the box, okay, in this particular direction. Now suppose this is around force of 10 newtons, and now the box is trying to oppose it maybe with 5 Newton. Now, this definitely the box is trying to give an opposite reaction, not necessary. Suppose if this was not opposing at all, if this is the same person, okay, only 10 Newton was there, and then this would have 0 Newton. You would have no efforts in pushing. It would move very quickly. Okay, what would happen? You just had to touch the finger and it would just move just as it is if there was no opposite reaction. But what is happening? The box will have certain weight. So depending on how much weight it has, it will try to give that much force back, try to resist. That's why you find it little difficult to push the box. Not as easy as if this was having no opposition. You would have pushed it very easily compared to this box which is trying to resist it. The heavy box. So that's why if you are very heavy stone, if you have of 20-30 kgs and all, for you it will be very difficult. Same like how if you are trying to push a wall, it will never go ahead because the force which is the wall which is giving it back to you is more than how much you are applying on it. Okay, so now what is happening? The action and reaction is acting on a different body. Action is on the box and reaction is on whom? On the person. Okay, so action is on the box, reaction is on the person. So action and reaction always have to be on the different bodies. Otherwise, what will happen? In this case, this is coming from the same body. Okay, the hanging one, tension. This is also from the same body. This is also from the same. Action is also from the same body. Reaction is also from the same body. Now what is happening? This will always forever remain at rest. There is no acceleration because these forces will always cancel out each other. If they acted upon a same body, the resultant force will always be 0 and there will never be any acceleration. It will always be at rest. So they have to act on different bodies. So this is what the second point means. Third point, the forces of action and reaction cannot cancel each other. Because otherwise what will happen? Nothing will move on this earth. If every force was trying to cancel out each other, no, then there would be no movement. Everyone would be at rest. Nothing would have moved. This is because action and reaction are on different bodies. React what I say. This is because action and reaction always act on different bodies. So does not balance each other. Also cannot balance against. Same like that cupboard and the man example, you remember? Or cupboard or a box and the man example. If it balances, it will never move. So something has to disbalance. Some force has to be more than the other. And the last point, no action can occur in the absence of reaction. Best example is tug of war. When a tug of war you can play when there are some people on this side, some people on this side. Imagine all the 10, like there are 10 people, they all are standing on one side. Can the game happen? No, because there has to be someone there to give this fight back on the other side. There no action only can take place if there is no person for the reaction. Okay, I'll give you that in words. A tug of war will happen only if there are people on both the sides. If no one is there to pull the rope, there is no game. There no one will win only. Means team A will be by default winning, but that is not the case. It should happen. So tug of war, can give an example. In a game of tug of war, one can pull the rope only if other team is pulling on the other side. No force can be exerted. On the other end is free. Like how other end is free, the person doesn't have to even apply force. What's the point applying force? There is no one to resist it. So rope will automatically come there. So there's no force. If then the other end is free of the rope, not need of force to be applied. So it will not happen. That action of tug of war, the game of tug of war will be incomplete because no action can occur in the absence of reaction. So this is all about Newton's third law of motion. So now next week I will not take class because of the exams. So next Monday I will start the same chapter only, but a different topic, that is friction. I'll stop here. Those whose exams are over can always revise the previous chapters. Okay, to attendance. Those are finished? Can